And I'm thrilled to announce that Jensen himself is here today. He's going to join me on stage. We're going to spend a few minutes chatting about the partnership, and we're going to see where AI infrastructure goes from here. So with that, let me please welcome to the stage Jensen Huang. What's up, Jensen? How you doing?
Boy, that's a huge stage.
Good
I
to
had run a long ways.
Are you out of breath? You okay? I know. Let's fire up. Good to see you.
大家好.
There you
Nice to
go.
see you.
Yeah. Congrats on a great kickoff yesterday, GTC. You guys are off to the races this week.
Thank you.
Look, maybe you heard some of what I just said. So we're talking about connectivity today.
The next $1 trillion company, ladies and gentlemen.
Whoa! That would be exciting. Let's do it together.
Yeah.
Let's do it together. But it really all starts with what's happening today in AI infrastructure kind of more broadly. So how do you see that, like just from the big picture standpoint? We're at this extraordinary moment, customer demands through the roof. How do you see connectivity playing into this and the interconnect that's required?
Yeah, that's really great. You know, yesterday I said that useful AI has arrived. It's the reason why your demand is going through the roof. It's the reason why my demand's going through the roof.
Yeah.
And this new computing pattern that makes it possible is called agents. And these agents has a particular computing platform, a computing pattern that is disaggregated and distributed.
Mm-hmm.
When you take a computing problem and you disaggregate it into a lot of parts and you distribute it across the entire data center, what's necessary is connectivity. That's the reason why Matt's doing so well. That's the reason why Marvell is so essential. We've distributed and disaggregated computing so that it runs across these enormous clusters so that we could get, we're aggregating the total compute, the total memory, the total bandwidth that we have. And what makes it possible is connectivity.
Yeah, we're seeing it. And then as you
That's
think
why
about,
they're going to be the next $1 trillion company.
we got a little work to do, but we're on our way. We're on our way. Thank you, Jensen. Well, let's talk about scale. I mean, we used to talk about tens of GPUs and CPUs and XPUs connected, now thousands, now maybe millions at some point. So as you scale the compute and you scale the connectivity, I think we talked about things like agents, but how do you think about that, across data centers, within data centers? How do you think about connectivity at large playing that role? And what kinds of technologies do you think are important there?
Well, at the foundation of it, the agent computing pattern requires an orchestration system that allows the large language models, the computing, to be able to think and reason and come up with plans. But it also has to use tools and browse the internet, access memory, access long-term memory, deal with short-term working memory. All of that requires a lot of connectivity. But it's also the case. And if you look at the way we introduced Vera Rubin, Hopper was designed for training.
Yeah.
Grace Blackwell introduced NVLink 72, our first scale-up fabric. It introduced the idea of extremely fast inference for MOE models that are very large, mixture of expert models that are extremely large. And so Grace Blackwell was for inference. Vera Rubin is to run agents, which is the reason why the Vera Rubin system includes, of course, the Vera Rubin thinking AI, but it also includes Vera CPUs for orchestration. It includes Vera CX for storage acceleration, for managing long-term memory. And the way that I think about these systems, sometimes maybe the CSP wants to design their own custom chip. And between us, we also partner together on NVLink Fusion, which makes it possible for you to use the same system architecture and with Vera Rubin inside, some of your semi-custom chips, a lot of your interconnect, silicon photonics and optics and technology such, and we can create essentially a disaggregated, distributed, and heterogeneous data center. And so that's the big idea.
Yeah.
And yet their system architecture is identical. Their networking technology can leverage a lot of NVIDIA stack. The CPU could be Vera, and yet it can leverage a lot of your stack. So NVLink Fusion is about taking NVIDIA's technology and our platforms, Marvell's technologies and we fuse it. That's why it's
Yeah.
called fusion.
Yeah. No, I think, I think about the partnership, and we've been working together a long time. I think memorializing it with the investment, which we really appreciate, I think it's been huge for us. We're honored to have it.
Who doesn't love making money? It's nice to give.
It's done well since you invested.
Boy.
So,
I
when Jensen invests,
love
just follow
getting
him.
rich.
Just follow him.
Give Matt all my money and just watch him make money.
That's what I'm doing every day.
I love that.
That's what I'm doing every day.
Yeah.
But I think these things you talked about, which we brought to fruition, NVLink Fusion, working together on optics. I mean, I think the era of agents and kind of your new platform now, I think it's ideally suited. I mean, NVLink Fusion, we had this idea years ago, right? But I think it was a little ahead of its time. And now, and I wanted to see if you agree, when you think about kind of your platform and then some of the custom networking and compute needs that our customers have, and the ability and the need to interoperate and work together, it seems like the time is now between Marvell and NVIDIA to really go enable our customers to have that flexibility that they're looking for and really use the era of agents to scale our platforms together.
Yeah, ultimately, I do think that if you buy nothing but NVIDIA, it's okay. Okay? I mean, if you absolutely must design your own ASICs, we're still happy having NVIDIA be inside that data center. And so, you don't have to buy everything from us. Just buy something from us. We're happy to support you and support the customer. And so I think that between the two of us, you have the benefit of a general purpose, very high efficiency, a system that is very well built, starting with, of course, Vera Rubin. But anything that you want to extend to specialize, you can do so as well, which is the reason why your customers and mine, NVIDIA's in AWS, Marvell's in AWS, NVIDIA's in all of the clouds, and it's wonderful to see Marvell expand into all of these different clouds.
Yeah, great, thanks. Hey, one last one for you.
Just leave some business for me,
Look, we're your best salespeople right now. Well, you have great
I'm
salespeople.
your best salesperson.
Working together. Final question for you. A lot of my talk is about some of the transition, especially as you go to inside the rack from copper to optical. It's obviously not going to be a 1-0. It's going to take time. There's time and there's different use cases. But how do you see that playing out right now, the transition from copper to optics, and maybe how we can work together there too?
Well, we should use copper as much as we can for as long as we can, but copper has its limits. Copper has its limits with bandwidth and also with distance. And so ultimately, the right strategy is to scale up with copper as long as you can. After that, you scale up further with optics, and you scale out with optics, and you scale across with optics. And so you use optics wherever you must. You use copper wherever you can. And so I think that intersection is going to continue for a long time. Here's the bottom line is, in the next 5-10 years, we're going to use a ton of copper, and we're going to use tons and tons of optics. And so these data centers are part of infrastructure now. And the reason why I say that AI is now useful AI has arrived, is because now AI is profitable and tokens are profitable. When token production is profitable, everybody wants to make more tokens, which is the reason why, Marvell's demand is so high, our demand is so high, because everybody wants to produce more tokens because it's used all over the place by agents.
Yeah, absolutely. Well, I think you touched on a bunch of things I'm going to cover later. If you want to do the rest of my presentation, you can.
Yeah, so ladies and gentlemen.
These beautiful slides,
Hey, Matt, just sit right there. I'll be.
Yeah, you take it from here. All right, Jensen Huang.
All right,
good to see you, brother. All right, take care.
Okay, guys, thank you.
Thank you, Jensen.
Bye, Marvell.
Bye, Marvell.